Hello everybody, and let's move to the cross project part. And let me show my screen. So I believe you already have this tasks and the guidelines for your cross project, and I do not I did not attend the last time cross project meeting. So have you do the cross project task last time? I believe Dr. Ennis will uh, help you to solve this task 7, right? So today we are going to solve the task 2 and the task 3. They are all related to the information theory uh, and statistical coding format. And in this task, we will use this part and the source probability distribution and for the Huffman or Shannon-Fano source coding in our project, and everybody will have its individual parameters, and we need to do the Huffman code and or the you see here. So everybody will only need to do one source code, Huffman code or Shannon-Fano code. I don't know, and it depends your number here. And I will introduce the both of them. And the first idea is uh, we need to do the source code, Huffman code, and Shannon-Fano code firstly. Then we move to the this one, the example, statistical coding example. We need to use this one called the word names. How to say average code names? We need to use this part. Then we can do the uh, task. We can do the task 2 and the task 3. However, I will use the this code words directed code words code wordness, and you can follow me to do this, and you just need to replace uh, your individual code wordness. That's that's enough. Then you will get your out your results have different uh, conclusion. And for the Shannon-Fano code, and you will see the code wordness and the Huffman code wordness, they are quite different. And let's get started. And first, we still hope to introduce how to do the Shannon-Fano code and Huffman code in our course project, because we have the much more simple if we compared with the previously case. So let's get started. The the first step, both of them to rearrange the symbols by their probability in the decreasing order, and choose arbitrarily if there are some multiple symbols with the same probability. So, which means you can see a symbol A8 and A9 will have the same probability. So uh, uh, you can arrange the A9 will be the biggest one, also can possible. So first we will introduce the Shannon-Fano coding, and the algorithm we already introduced in previous course. And first is sort the source code with the probability decreasing order, and divide them in two groups, and will equal to the equals total probabilities, and assign the one symbol to the subgroup and 0 symbol to the second subgroup, and continue the further division of each subgroup. And quite important here, read coordinates from left to right. And let's do it. And first binary symbols will be the subgroup will be the here and the green color part and red part, orange color part, and you will see we arrange the A8, A9, A2 as one group, and the A1 to the left part as the other group, and we calculate the total probability of them with the first is 0.44 and the second green color part, and the other part will be the 0.456. However, if you want to add one more here to the green part, and you will see here will be the 0.56, and here will be the 0.44. They're same, and also be the you can also you can also add this for as one group, which will have same probability here, and we can go on. And so for the green group part, we still do the second binary code with the second supplement, second division with the first with 0.415 and which will be the first subgroup is 0.15, and the second subgroup will be the person will 0.29, and maybe possible alternative choice will be you add these two together, and you will get this another subgroup. However, I recommend to choose some minimal difference between each group. You will see if you have here and the group of both group is the difference will be the 0.14, and this difference of the both subgroups is 0.16, a little bit higher than this choice. So maybe this choice will be the better choice. And the second subgroup will be the here, and for the this one and this two as the 0.24 and the the left 4 samples, add them together as the 0.32. And don't forget to assign the number here, each of group with different number 1, 0. And next we third division, and same with we only have two symbols, so we just assign them the 1 and 0. That's enough. And the second subgroup with the we add them these two together, so it only has one and has only the only symbols, so it only has one is 1 and the other is 0. And here we still do the some subgroup with these 4 symbols, and you will see here, and of the subgroups will have some two. So we submit with them two subgroups and two symbols with 1, 0, and the first binary symbols will only the 1, 0 and the 1, 0. That's enough. So we read the code words from the left to the right, and 1 1 and 1 0 1 and 1 0 and some left here and here, here, here. So high probability we has the short code word length, and low probability we have long code word length. And for the average code word length will no, it's only the code word length will be the average code length will be the, here we have 2 code word length, 2, 3, and or here will be 4. So the M0 is here is no, and just 0 and 1, 2, and this is 1 and 2, and go on so on. So that is our code word length for the Shannon-Fano coding, and we will use it to calculate in course project task. And the Huffman coding algorithm will also be the, as we introduced previously, same sort the source symbols in probability decrease order, and selected symbols with minimal, and merge them to the probability, and send 1 to the upper branch, 0 to lower branch, same to the, and stop at the probability of the merged symbol as the 1, and read the code words from the right to the left by following the code tree branch. And the first step, we can merge them together because this is minimum probability. Probabilities the 0.06 and 0.7, and we will get this. So, however, we just don't need this part after the merging because we just calculate here. So up there, and we have this, and we cannot merge them. It's 0.13 because it's not the minimal probability. So after that, these two symbols will be the minimal probabilities. Now we need merge them together, and also here these are two minimal probabilities, and now we have the minimal probabilities is the 0.14 and 0.13. Just merge them together. Don't forget to assign the upper branch and the lower branch the number 10, and it can get reached to the 0.27, and well, so now here that is we have 1, 2, 3, 4, 5 left samples. We need to, and this two is the smallest samples. We just merge them together, and now we need to merge them together because they are our minimal choice. So we just, how do you say, just do some move to here, so it's same, not change anything. Did not change anything, and we only left here 3 symbols, and similar. We merge them together. These two, and we got only 2. Then just merge them together, we get 1. And we need to read the code words from the right to the left, and go like this from past 1, and next we also pass the 1 and pass the 1. So each of them can reach to the branch from the, read the code by following the branch from the code tree code root, and we can get our code word, and we can get our average code word length, and with the average 0 symbols code word length and 1 symbols code word length. Okay, so that is the idea, and let's come back to the course project part, and So task 2, we need to prepare a calculation program and MATLAB, Python or C. And here we use Octave for analysis of the data source based on the specific probabilities of each symbol calculated as following. First is the source entropy and the maximum possible values, and for the source redundancy, and it's already given for the calculate of the source parameters. First, we use the follow. We need to calculate source entropy. We need to get the probability distribution, and we can calculate the maximum entropy and source redundancy. Let's do it in Octave. And first, we just in the previously. And, this one will be the probability for source 74, because we use this Dr. probability distribution. You will use your individual probability distribution, and we still need to specify some parameters like symbol duration. Well, it can find in here your symbol duration is nanoseconds, so we should here change the unit to the second. And for we specify the symbol duration time will be the 60 to change the unit here, and will be the symbol duration seconds. And we will write its probability distribution like this 74, and from the A1 to the A9. It will be the probability distribution will be 0.12 and 0.14, 0.07, and 0.11 and 0.2, and which is 0.06 and 1515. And we need to so it has the different order. We need it has decreasing order, so we use a function to do that, and use the sort function. Just the p, the descendant. Dot in descending. We also can check it to we did not have a mistake, because the result will be the one for the different symbol distribution. This is tasks 2 and task 7. So it's correct, and the total probability will be the 1. And you will see from this variable workplace variable path, you will see your distribution board has some specific order here. Yes, let's delete it, and from the highest probability to the lowest probability. And we did the Huffman codes. First, we can do the Huffman codes. Here we use this one Huffman codes, code wordsness, and m will equal to here 1, 2, 3, 4, 5, 6, 7. Then we can do the M0 and 0 0, 1, 1, 0, 1, 1, 1, and 2, 2, 3, 2, 2, 3, 2, 3, 2, 3. And for the M1, so the 3, 2, 2, 3, 2, 1, 1, 0, 2. We can check it whether the M1 plus M0 will equal to the M. Just the M0, M1 will to M. Same. Yeah, it's same. So it will be same. And we can calculate the source entropy. We see the function definition like this. So we use the minus, negative, and to sum them each of simple probabilities multiplied with the logarithm. And it will be the task 2. Source pair task 2. And for the source entropy, H will equal to the minus sum P multiplied with the log 2, and with the log P here, and that will be the source entropy. And we also can use here. We also can use the vector multiplication method, and with minus p here, minus p, and multiplied with the transpose of the P. So it can be like this, minus P multiplied with the log 2 P prime. So let's check it. Different. Yeah, they're same. So both methods can calculate the source entropy. Next, we will calculate the maximum entropy, where n is the number of the symbols in the alphabet. So we can calculate the n is we use the length of the mass function of the p. Length of the length of the probability of the p, and we can calculate the max will be the log 2n. Maximum entropy, and we can calculate the source redundancy with use this rule, and use the source entropy over by the maximum entropy and use 1 minus it. So can define as capsule P, and with the 1 minus this h with the h max. So we can see the result here, and you will see here our redundancy will very low, and our the efficient is quite high, can almost reach to the maximum entropy. You see here, quite good. So, and so we can calculate the next part. The task 3. Perform source coding, Shannon-Fano code, and improve the program task from 2. And we need to calculate average code word length and the probability of the 1 and 0 symbol and binary entropy, and the source data generation rate after coding, and the compression rate. And we need to use the following entropy. Let's do it. So first is average code word length, and average code one we can also use the matrix calculation. Okay. And then go to the p. Yes, here p multiplied with the m prime. M prime will be the average code word length. And M0 will be the p multiplied with the is the number of the 0 symbol and the 1 symbol. M0 prime. Just copy it. So 0 and 1. That is quite easy method, and we can calculate the probability of this, and P0 will be the M0 divided by the M average. P will be probability of the zero symbols. So let's do it, test it. So we can get this, and the probability you can see here are quite good. Can both of them can reach to the 0.5 probability. And next we will calculate the binary entropy, and for this one we use the probability, and yeah, we only use the probability of the 0 and 1 symbol. So H binary will equal to minus P0 and multiplied with the log 2 P0 minus then P1 multiplied with the log 2 P1. Binary source after coding. Let's check it. And well, it quite can reach to the 1 bit. We can get the highest and 1 bit. And the data. Next, we'll calculate the data rate. Where is the tau? We need tau h, the entropy of the A symbols, and the tau and the average length of the code length. Do it, and with the R equal to the H. H will be the source entropy with M average with the data rate. And the compression ratio. Use the average codeness to divide with the source entropy. compression ratio. Okay, so let's do it. And here, well, it almost reached to the data ratio count. Yeah, it can reach to the 16.5 megabits per second per sample. And the ratio, the compression ratio reached to the 1. Well, is also quite good. So this is only for the Huffman code. We just change here. And for the for Shannon-Fano code, just using this part to replace with Shannon-Fano code average coordinates and two. And for the M0 will 0, 1, 2, 0, 1, 2, 1. And for the 2, 3, 3, 4, 2, 3, 3, 4. And 2, 2, 1, 2. 1, 2, 1, 1, 0, 1. And this is for the Shannon-Fano code 1 length, and it will be the yeah. That's right. And yeah, they are okay. They are, I would say, almost similar. You will see Hmax also can a little bit different. I do not believe that the difference between the source entropy to the maximum that for the Huffman is 0.02, and here is only around 0.06, and it shows the Huffman code has better performance than the Shannon-Fano code, and the speed that the data rate also has the you see here 16.3 bit, and previously we have the 6.5 bit megabit per second. So that is their difference. And please do not forget to do your course project task and make your own conclusion and about this one. And so today's class is over, and thank you for your attention. Do you have any questions?
Yes,
Hello,
sir, but I don't know how can I say in questions in the code in the how do you say in English guillemets? I don't know.
Sorry. I
Uh,
Tu peux répéter, s'il te plaît?
Comment on dit guillemets? La signification de guillemets dans le code, c'est quoi?
J'avoue, je dirais quote, mais
Ah,
ce
tu veux
serait
dire
plus
ce que t'as fait?
citation.
What does it do in the code?
Yes, in the code, what is the code, the quote in the, for example, line 35?
Code? You mean
Yes.
for the course project part?
No, for
Come back in the code, sir, please. There is a quote line 35. And he wants to know the purpose of the quote.
a quote quotations mark
Code conditions?
or comma.
In the code.
What is this mean?
What code dimension?
Yeah,
So,
sir, in the code, in the MATLAB code, or in the code part. Like previously you wrote a code. Can you please come back to the code section?
code section here?
Yeah, this part.
Yes, which part did you understand?
Yeah, and line 35, you use quotes.
35. Here?
After the M, after the M, you use a symbol. What is the meaning of the symbol? What is the purpose?
Yes, this you don't understand here. So average codeness will here. If you remember, we used the two ways to calculate the source entropy, right? And we just like the P. You know, P is the I explain here, and yeah, the P is like a vector with like this. So we just transpose with the P and as this. So it will like calculus, and all of the elements will like multiplied with by each other, and plus with this one and this one, right? So here's the same idea for the average code worthiness. And if you see here, average codeness, that is also the multiply them and plus them together. So we use this here, MP, that is also our vector, and we just transpose by the M, which means M will be the M, yeah, M also will same and multiply the M. No, this is not correct, and we just transpose it as this part, and we can get like this formula. It will same with you can replace this function.
Okay.
You understand?
I understand.
Yeah, it's just how to say in linear algebra and idea. Yeah, it's just like this.
Okay. Thank you, sir.
Okay, thank you. Thank you. So today's over, and see you guys next week. And don't forget your course project part. And bye bye.
Thanks. Have a nice day.
Thank you. Yeah, nice to meet you.